Hello everybody and welcome to a 3-video series of MySQL InnoDB Cluster and MDB Cluster. The first 2 videos are InnoDB Cluster. This one is the single primary setup or mode for InnoDB Cluster, where you have one single primary for writes and then 2 secondaries for reads, and then we extend it to another secondary. In our demo, I'm running everything on one single machine on my laptop. In reality, it will be separate machines with their own IP, and there is shared nothing. So each machine is completely self-sustained and standalone, and they are connected through the X protocol and replication to maintain synchronization. We are starting with an empty machine. And the first thing we do is we connect to MySQL shell, which is part of the MySQL InnoDB cluster. The shell is just an administrative interface to deploy and to maintain your cluster. So it's just an easy way. It speaks JavaScript, Python, and SQL. Currently we are in JavaScript notation, as you can see in here. And this is why the commands will look very similar to JavaScript. First thing I'm doing, I'm creating a variable called dbpass. This is a name I chose. You can choose whatever name you want, and it's an empty password. Now, don't run your production with empty passwords. For the demo, it's right just to make my life easy when I'm running stuff. But in production, always use passwords. The next thing you do, we're going to deploy 4 sandbox machines. Now, the reason we're deploying 4 is we're going to use 3 initially, and then we add another one. Our minimum cluster is going to be 3 machines, and 4 is actually not a proper cluster. A proper cluster is an odd number of machines, so either 3, 5, 7, or 9. For the demo, it's okay to use just 4, but it's not good, or it's not acceptable or best practice for production. Our machine is going to have 4 different ports because it's running on the same machine, so localhost, and the different ports are 3310, 20, 30, and 40. And initially, as I said, we're going to use just the 3 first ones. So now we have the machines up and running, and those are just instances. There's nothing; they are not in cluster in any way. They're just running. We have to set the cluster in a second. The next thing I'm going to do, I'm going to quit the shell, and I'm going to run some very simple loop to set up a root password with no root user without password. Again, just for the demo, don't do it in production. With the old authentication plugin, the MySQL native password, and that's because I'm running a PHP application for this demo, and my PHP does not support the new authentication plugin. So if you have issues with your application in version 8, which is the version I'm using, MySQL version 8, it might be because of authentication plugin, and all you have to do is just create a user with the old authentication user, or set it up as a default. And now we're going to go back into the shell, setting up again the empty password, and we are connecting to the first machine, 3310, and now it tells us that we are connected and SSL is enabled, and we are actually, as you can see, now inside the actual server. This is a version 8, and that's the command that basically create our cluster. So we create an object called cluster. I'm calling it cluster, you can call it whatever you want. And we use the class DBA and the method create cluster with the name CL. This is just a name I'm using. I'm lazy, so I'm always using short names so I can type them quickly. In production, use proper names that actually tells what this cluster is doing, so it will make sense to you. And the setup of multi-master into false, that means it's a single primary. The second video, we're going to set it up to true, which is multi-master. But in our case, it's just a single primary. So as soon as we issue this or creating this object, it will bootstrap the cluster, create all the structure that needs to be done, and add the first machine into the cluster. So it actually tells us that the cluster was successfully created, and we should use the method add instance to add more instances, and we need, as I said, at least 3 instances for a proper cluster. This is the minimum amount of machines you need in a cluster. So let's add the first one, which is the 3320, and that will be the second machine in our cluster. It was successfully added. And now let's add the third one. And if everything works well, we're supposed to have a running cluster at the end of this. Let's have a look. So we use the method status on the object cluster, and it tells us that we have a cluster and the name is CL. Yeah, that's what we chose. And it's okay. And the status text is the cluster is online and can tolerate up to 1 failure. That's good. We have the topology. So we have the 3 machines. And this machine is our primary. It accepts read and write. And the second machine is read-only, secondary, and the third one is read-only as well. So that's great. That's what we wanted. We can now exit the shell. And the next thing we're going to do, we're going to bootstrap the router. So the router will read the topology from the cluster and configure its routing rules accordingly automatically. So we have the classic MySQL protocol, listens on 2 ports. So read and write will listen to 6446, and read only will go to 6447. So the application, my PHP application, knows about only those 2 ports. It doesn't know anything about the underlying cluster, what ports they are listening and who is the primary and who is the secondaries. The application knows nothing. It just knows about the cluster. We also have the X protocol on 2 different ports. And the X protocol is a NoSQL interface. If you don't know what I'm talking about, you should Google MySQL document store. That will explain. It's a NoSQL interface into your relational data. Very nice and exciting. All I have to do now is just run the router. So the router is running, and then we can go into our PHP application, and now we're going to choose a single primary InnoDB cluster. And so our application is connecting to our servers, and it shows us that the servers are up and running, and we can start the application. So you can now see that the application has some transactions coming in and some BI happening over here. And clearly you can see that the first server is used only for writes, and the 2 servers, the 2 other servers, are only for reads, and it's split almost evenly between those servers. So yeah, our cluster is working and providing service to our application. So all the reads from this application goes to 1 port, and the writes to a different port, and the router makes sure that it goes to where it's supposed to go. Now the most worst disaster we can have for this cluster will be losing the primary. Obviously, if you're losing the one of the secondaries, we have the other one. That's not impressive at all. But if the primary goes down, that means that we have a major disaster, and this is exactly what we're going to do now. So we're going to stop the first instance by connecting to the shell again and just stopping the first instance. Now you'll see that as soon as we stop it, there is a bit of time it takes for the cluster to realize what's going on, and immediately after there is an election of a new primary, which tends to be the second one. And now the second is the one that accepts writes, and the third one is the accepting the reads. Now the router, after the cluster decided decided that we had a disaster and needs to adjust, and the cluster did its job by electing a new primary, and the router readjusts itself. So again, the application writes to the same ports. The application has no knowledge of anything that is happening. Now we came in the morning and we found out that our primary is turned off, and we need to start it up. Now obviously, while we're starting it up, you will see that it's behind with its transactions. So you can see in here the number of transactions that those servers has. You'll see that the new one will have a lower number, and it won't accept anything. It won't join back to the cluster and the router won't adjust to read from this cluster, from this server, until it's fully catch up. And that's exactly what's going to happen. So we're starting it up. We're waiting for the server to go up. And you can see that it's behind and it's immediately starting to catch up. It will ask for a donor. One of them will be the donor for this server. And as soon as it's catching up, the router will rejoin this server back into our cluster. And now reads are going to go into the first and the third one. Now there will be no failback. There is no meaning and no reason to turn the first one again into primary. It's just they're all the same, so there is no need to do it. It doesn't make anything. And you can see that the application kept on running. So the application had no stop, and it just kept on running, which is exactly what I wanted. This is why we use this HA solution. Now, with our demo, I could just start the machine. It would catch up. If the machine is completely wiped out, and it has a lot of data in it, you will need to do an initial load, which is done by backing up one of the other servers and restoring it into a new server and then joining into the cluster. It looks the same, just additional steps to do on the way. Okay, so we finish recovering, and now we can go into extending the cluster. And as I said, and I'm going to change the demo into the extended cluster, which has 4 machines. And as I said, running 4 machines is not best practice. So you shouldn't run a cluster with an even number because of majority and all sorts of stuff. But for the demo, it's good enough. So now we have the 4th machine is still not part of the cluster. So we're going to add it. And the way we do it, we connect to our MySQL shell again, set the empty password. We connect to our second machine, which is the primary. We have to connect to the primary as we are going to write stuff. And the only machine that can write stuff is the primary. All the rest are in read-only mode, super read-only mode actually. And now we're going to create the object cluster again from the existing cluster. And we again use the method add instance. So we're going to run this, and hopefully this machine will join to our cluster. We'll have to wait. And then obviously it will go into recovery and we'll need to catch up. So it was add to the cluster. And if we look at the status, it's now recovering, and you can see it's now catching up with the transactions from the other machines. And it won't join and it won't go online until it catch up with the rest of the machines. So it's from 0, needs to catch up with everything that happened since the cluster started. In reality, we can do it here in the demo because we just started and the cluster was empty when we started. So as you can see now, the server is online. So this machine is now online and it joined to the router. But it's important to mention that in reality, when you have a cluster that was running for a long time and it has a lot of data, it won't be able to catch up because it doesn't have enough binary logs to recover. So you need to do what we call initial load, which is a backup of one of the other servers, and dump it on the new machine before you join it. And then you join and it will just catch up with the changes via GDITs. Now, to do the backup, we recommend MySQL Enterprise Backup, which will be the tool that it will be the easiest to back up one of the other machines without affecting the service. That's it for this demo. See you on the next demo.